Hi, friends. I hope you guys are so ready to put on your dancing shoes because today's the last day of Module 1. So a little party to celebrate. So today we finish up Topic F, addition and subtraction word problems. And today's lesson is going to look a little different than what we've been doing the past few days. So we're going to go ahead and get started. We're going to create and solve multi-step word problems from given tape diagrams and equations. We're going to do this to gain a better understanding of word problems, tape diagrams, and how to solve word problems. Today, you're going to know you're successful when you create your own word problems and solve them using the RDW, the read, draw, write process. So let's go ahead and get started. As I said, it's a little different today because you're going to be the one solving your own word problem. You're going to create a word problem based off of either the numbers or the tape diagrams that they give us. So the tape diagrams are made, but we have to kind of look and decide what this looks like. So we're going to create and solve a simple two-step word problem from the tape diagram below. So here you can see our total is 7,104. A section of it is 4,295. A section of it is 982, and a section is unknown. So our suggested context is people at a football game. Okay, so I'm going to start off by, we have 7,104 people. So I'm going to write it over here. There are 7,104 people at a football game. And we have to have different things for these three items. So I'm going to go ahead and say that this represents like men at the football game. This represents women at the football game. And so we're trying to figure out how many kids are at the football game. Okay. So we're going to say there are, because each of these have to represent, our numbers have to be represented in our word problem. There are 4,295 men at the game. There are 982 women at the game. How many kids are attending the game? Okay, so now that we've given everything a name and a section and a number, what you're going to actually do is go through and solve it. Because we got to make sure it all makes sense and make sure our question makes sense. So, because we also have to create and solve a simple word problem. So there's two ways that you could do this. You could take your total and subtract men and then subtract women. I'm going today to add up my men and women to see how many men and women are at the game. So 4,295 plus 982. We have 5 plus 2 is 7. 9 plus 8 is 17. 9, 10, 11, 12. And 4 plus 1 is 5. So we have 5,277 adults technically at the game between men and women. So now if we were solving this, we would have to take the adults away from our total to be able to find our students or our kids. 7,104 people are total minus our adults, which is 5,277. Notice my big number is on top. Notice that my place values are lined up just like we've been doing this entire module. 4 minus 7, I cannot borrow from the 0, so I'm going to come all the way over here to my 1, turn it into a 0, make this a 10, I'm going to borrow from it again, make it a 9, and I'm going to make this 14. So 14 minus 7 is 7, 9 minus 7 is 2, 0 minus 2 I cannot do, so go next door. 7 turns into a 6, my 0 turns into a 10. 10 minus 2 is 8, and 6 minus 5 is 1. So this should give us our answer of 1,827. Since we're solving it, we're still going to use our RDW process, so I'm going to write my answer as a statement. There are 1,827 kids at the football game. So we did all of the things. We labeled them each. We know how many men, women, and kids were at the football game, as well as created a 2-step word problem. So we did a 2-step word problem. We found our answer. So that's what you guys are going to be doing today. They are going to look very similar. I'm going to give you guys a few more examples, though. So our next one is the cost of 2 houses. So again, we're going to create and solve a 2-step addition word problem from the tape diagram below. So the suggested context is the cost of 2 houses. It's not very often that I would get to have 2 houses, so I'm going to act like one is my lake house and one is my actual house, which I don't have that, but I wish I did. So I'm going to say that this is the price of my lake house. And then this is the price of my home in town. You also could say like house A or house B, but I just like to imagine that I have 2 houses. So the way that we would do this is that we know that our lake house costs $215,554. That one's labeled. But our home that we live in most of the time is $90,457 more. We can see this from the tape diagram because that's the more space. But our overall question is, what am I paying for both houses? So everything I just said, we're going to write into a word problem. So my lake house costs $215,000 and $554. My home in town cost how much more? $90,457 more than my lake house. But remember, we need a 2-step word problem, so that would help us find the price of our home. We need to know how much both of our homes cost altogether. So my question is, how much do both homes cost altogether? That helps our readers know that we're trying to find out the grand total between both of our houses. So we're going to come over here and solve our problem. Again, this is a great time for you to pause, find the answer on your own, and then come back to me, but I am going to solve it here. So the first thing we need to do is find the price of our town or our home that's in town. So I need to add 215,554 plus that extra 90,457 to be able to find our home that we live in every day. So 7 plus 4 is 11. 5 plus 5 is 10, plus our 1 is 11. 5 plus 4 is 9, plus 1 is 10, so leave my 0, carry my 1. I'm going to put my comma there. 5 plus 1 is 6. 9 plus 1 is 10, so I'm going to leave my 0, carry my 1. And 2 plus 1 is 3. So our everyday home costs $306,011. Now, I can't afford that, but it's fun to imagine. Okay, so now we have to find out the total of both. So although it looks like we already added in our lake house, we haven't. This is just the price of our actual home. So now we need to go back and add 215,554 because we need to find out the price of both houses. So 4 plus 1 is 5. 5 plus 1 is 6. 5 plus 0 is 5. I'm going to put my comma. 6 plus 5 is 11. 1 plus 1 is 2. And 3 plus 2 is 5. So we got our answer. We did do a 2-step addition word problem, which we did all of addition. So everything so far in our word problem would make sense. And I'm going to go ahead and write this as a statement. So the 2 houses cost $521,565 all together. Okay. I'm going to show you 2 more samples. So this one, it says to create and solve a 3-step word problem involving addition and subtraction. On this one, I'm going to simply help you set up the problem. I'm not going to help you solve it. So I want you guys to go through and solve it, and then we'll kind of talk about it. So they want us to do weight in kilograms of 3 different whales. Okay, so here we must have whale A. We have whale B, and then we have whale C. Okay, so here we know for sure that whale A is 8,200, I'm going to just label it kilograms. But then we see here that whale B is less than our whale A, and it's less than whale A by 3,500. So that's going to have to be part of our word problem. But whale C is 2,010 kilograms greater than whale A. The overall question you can see over here from our question mark is, what is the weight of all 3 whales? So everything I just said, we're going to go ahead and write as a word problem so that you can go ahead and solve it. So whale A weighs 8,200 kilograms. Okay, so that part is done. Whale B. So we're going to say whale B. And you got to look. Does it weigh more or less? And when it says less, that means we're going to subtract, right? Whale B weighs 3,500 kilograms less than whale A. Make sure this B up here looks like a B. I think it got cut off. Okay, so far we have whale A and whale B done, but now we need to do whale C. And whale C weighs 2,010 kilograms more, right? They would have to add to find whale C. You guys are going to have to add more than whale A. Okay, but remember our overall question is, how much do all 3 whales weigh? So I challenge you to solve this problem. Make sure you understand all the pieces. Write it as a statement. This is your practice. So check in with your teacher on that problem. I'm going to keep going, though, so we can solve, and I can set up one more problem. Okay, so now we just see a word equation. Okay, so we're going to have to make a tape diagram and a word problem. So I wanted to cover this one because I think it was a little bit trickier for me. I'm used to looking at tape diagrams. So I'm going to go ahead, make a big tape diagram. And remember that when the answer is always up top on our tape diagram. So that's kind of our first step. So I'm going to actually draw this lower so that I don't get them kind of mixed up in here. Okay, so our total, whatever it is for our word problem, is 26,854. Okay, so we have a section of it that is 17,729. A section of it that is 3,731. I should have made that bigger and this one smaller. And then a section of our total that is A. And A is our unknown. So for today, we're going to say we took a survey and we're trying to see how many people like different kinds of juice. Okay, so we'll say that 17,729 people like apple juice, because that's my favorite. We're going to say that 3,731 people like orange juice. And our goal today is to figure out how many people out of that survey like grape juice. You could have done anything you wanted to. It could have been sports, it could be colors, it could be whatever it is, as long as it goes into the total. It could be how much money you made in a month, and this is how much you made in week 1, week 2, week 3. No matter what it is, you just have to describe in a word problem what they're trying to solve. So if I were to write this as a word problem, I'm going to say there were 26,854 people surveyed on their favorite juice. Whoop. 17,729 people liked apple juice. Sorry, my pen gets a little tricky there. 3,731 people like orange juice. And then our overall question is, how many like grape juice? And maybe I should have worded that as like maybe they prefer it, anything like that. So now if you were to come through and solve this problem, I will solve this one with you. It just looks kind of tricky, but I'm going to add up the two that we know and then take it away from our total, because then that's going to leave us with our grape juice. So I know that 17,729 people like apple juice and 3,731 people like orange juice. So I'm going to add those up. 9 plus 1 is 10. 3 plus 2 plus 1 is 6. 7 plus 7 is 14, so leave my 4. I'm going to carry my 1, cash it in. 7 plus 3 is 10, plus 1 is 11, and 1 plus 1 is 2. So we know that 21,460 people like apple or orange juice. So we need to take that away from our total to figure out how many would be left with grape juice. Minus our 21,460. 4 minus 0, my big number is on top. This one, my big number is on the floor, so I'm going to come over here and borrow. 15 minus 6, 14, 13, 12, 11, 10, 9. 7 minus 4 is 3. Again, my big number is on top, so I have 5. So this is what, and 2 minus 2 is 0. So I am left with 5,394. I've done everything so far. I've written my word problem. I have my tape diagram. I've solved my problems. Now I need to write it as a statement. So 5,394 people like grape juice. And maybe in my question, I should have added like from the survey, how many people from the survey like grape juice, just to have been more specific, because I don't want people saying, oh, well, 4 people in my class like grape juice. So maybe I should have been more specific. How many people in the survey like grape juice? And, you know, we make mistakes, so it's good to go back, reread your questions, make sure that they make sense when you're writing them. Okay, so now you guys on your exit tickets will be able to show us what you know. Use whatever you want to. You can use flowers or food or sports, whatever you like. Create your own word problems that match and then solve it in both of these ways. So good luck, guys. I can't wait to see the different word problems you come up with.